Good morning students. I am myself Rupinder Kaur. I am from SRS Government Polytechnic College for Girls, Ludhiana. Today my topic is functions, limits and its 4 standard forms. So first of all, we will define the term functions. Let x and y be two non-empty sets, then a function f. It is from set x to y written as f dots x to y or x to y is a rule. A function is a rule which associates to each element x of set x a unique element y of set y. That is, if these are two non-empty sets x, y, then function f is a rule which associates each and every element of set x to the elements of set y. The unique element y of set y is called the value of f at x or image of x under the function f and is denoted by f of x, that is y is equal to f x. Note that the set x is called domain of the function, domain of function f, and is written as df, which is equal to x, and the set y is called codomain of f. Now we define limits. First, we discuss the meaning of x approaching a, x approaching a. Now, x approaching a means x is not equal to a, but x minus a distance is very small. So, x approaching to a means there exists a positive number delta which is greater than 0. However, small such that 0 is less than x minus a mod is less than delta. That is, x belongs to open interval a minus delta, a plus delta. Now, we define limits. Consider a function f(x) is equal to x square minus 1 upon x minus 1 for x is equal to 1. Clearly, f1 is equal to 1 minus 1 upon 1 minus 1, which is 0 upon 0, that is not defined. That is for the value x is equal to 1, this function is not defined. However, as x approaches to 1, the value of f(x) approaches to 2. It is clear from the table. If we take the value 0.9 and put this value over here, then we get the value of f(x) as 1.99. For 0.999, it is 1.999. This is 1 point, and if we take the values from the other side, this is 1.001, then we get 2.001, 1.01. So, we see when x is approaching to 1 from the both sides, f(x) is approaches to 2 from the both sides. So, we define first we define left limit a function f is said to have a limit L as x approaches to a negative, written as limit of f(x) is equal to L, that is, if x approaches to a from the values lower than or less than a. right limit is a function is said to have right hand limit as x approaches to a from the values higher than a, and we write it as limit x approaches to a plus f x. Now, next is note that if limit of f x approaches to a plus is equal to limit of f x approaching a negative, that is from the lower side. These both limits are same and the value is L. Then we say that limit of f x approaches to a exists and is equal to L, and we write it as limit of f x approaching to a is equal to L. Means if both limits, right hand limit and left hand limit exists and is having the same value, then we say that limit of f x as x approaches to a equal to L. Now, some important results. First, if limit f x approaching to a exists finitely, then it is unique. Second point, limit of a constant number alpha is equal to alpha, where alpha is a fixed real number. Third point, if f x and g x be the two functions, then limit of f x plus minus g x as x approaches to a can be written as limit of f x as x approaches to a plus minus limit of g x as x approaches to a. Next is if the two functions are given in the quotient form, and limit as x approaches to a can be written as limit of f(x), x approaching to a upon limit of g(x) as x approaches to a. Next point is limit of f(x) into g(x) as x approaching to a is equal to limit of f(x), x approaching to a into limit of g(x) as x approaching to a. Now, next we will discuss the methods of finding the limits. First method is direct method. Second is method of factorization. Next is method of rationalization, and the fourth method is general method. Or H method, in which we will use the binomial theorem. So, first of all, we will discuss the direct substitution method. Direct method, that is direct substitution method. So, first example is limit of x square as x approaching to 2. So, we can directly put the value of x over here. So, we get 2 square which is equal to 4. Second, limit of 4x square minus 5x plus 3 as x approaches to a. So, we will directly put the value of x equal to a and get 4a square minus 5a plus 3. Limit x cube minus 1 upon x plus 2 as x approaches to 0. Now, if we put 0 over here, so we get 0 minus 1 upon 0 plus 2, so which is equal to minus 1 by 2. Next example, limit x minus 1 whole square plus 5 as x approaches to 1. So, this is equal to 1 minus 1 whole square plus 5. So, 0 plus 5, so answer is 5. So, our next method is method of factorization, in which we will make factors. So, first example is limit of x square minus 1 upon x plus 1, x approaches to 1. So, this is equal to limit x approaching to 1, we will make the factors of the numerator upon x plus 1, cancelling the common factor, limit x minus 1, x approaches to 1. So, 1 minus 1, the answer is 0. Second example, limit x square minus 1 upon x square minus 3x plus 2 as x approaches to 1. So, we can make the factors of both numerator and denominator. This is x minus 1, x plus 1, this is x minus 2, x minus 1. So, cancelling the common factor, we get limit x approaching to 1, x plus 1 upon x minus 2. Now, put the value of x, this is 1 plus 1, 1 minus 2. So, 2 upon minus 1. So, this is minus 2. Next example is limit x cube minus 8 x square minus 4 as x approaches to 2. So, this can be written as x cube minus 2 cube x square minus 2 square x approaches to 2. Now, making the factors, we get x minus 2 x square plus 2x plus 4 x minus 2 x plus 2 as x approaches to 2. Now, cancelling the common factor, we get the function limit x approaches to 2 x square plus 2x plus 4 upon x plus 2. Now, we will put the value of x equal to 2. We get 4 plus 4 plus 4 upon 4 plus upon 2 plus 2. So, this is 12 upon 4, which is equal to 3. So, value limit of this function is equal to 3. Now, next question, limit x cube plus 1 upon x plus 1, x approaches to 1, x approaches to minus 1. Now, the factors of the numerator are x plus 1, x square minus x plus 1 upon x plus 1, cancelling the common factor and putting the value of x, we get minus 1 square minus 1 plus 1. So, this is 1 plus 1 plus 1, which is equal to 3. Now, next method is method of rationalization. So, we use this method when the function have the terms having a under root. So, first example is find the limit 1 plus x minus 1 upon x as x approaches to 0. So, we will rationalize this function with respect to the numerator and get 1 plus x minus 1 upon x into 1 plus x, the term with change sign of numerator plus 1. Now, here this is the formula a minus b into a plus b, which is equal to a square minus b square. So, we get limit x approaches to 0, a square minus b square, that is 1 upon x 1 plus x under root plus 1. So, this is equal to limit x approaches to 0, 1 plus x minus 1 upon x 1 plus x plus 1. So, cancelling these terms and cancelling this x by this x, we get limit 1 upon 1 plus x plus 1 as x approaches to 0. Now, we can put the value of x. So, this is 1 upon 1 plus 0 plus 1, so 1 upon 2. Another example, limit 2 minus x minus 2 plus x upon x as x approaches to 0. So, we will rationalize this function limit x approaches to 0 2 minus x 2 plus x upon x, and we will multiply and divide this by 2 minus x plus 2 plus x upon 2 minus x plus 2 plus x. Now, in the numerator we have the formula a minus b into a plus b. So, which is equal to a square, that is 2 minus x minus 2 plus x upon x into 2 minus x plus 2 plus x. Now, this is equal to limit 2 minus x minus 2 minus x upon x into 2 minus x under root 2 plus x under root x approaches to 0. Now, cancelling these two, we get limit minus 2x upon x 2 minus x plus 2 plus x as x approaches to 0. Now, again we can cancel this x by this x and put the value of x, we get minus 2 upon 2 minus 0 under root plus 2 plus 0 under root. So, this is minus 2 upon 2 under root 2 minus 1 by